Good morning, everyone. Morning. So today we will presentate our final project after we doing it 3 months. This is all of our member. First is Azara Novanda Guska. Then there is Belva Mieko Suparwanto and Ibuta Suryono Sumbung. Then there is Gilang Rianto Utomo. And then there is Hasbi Fajrul Hakim. And then there is Muhammad Rafi Al Yahya. And there is Muhammad Agil Fadilah. And then there is Muhammad Ahsan Fikri. Then there is Muhammad Hussein Apriyanto. And then there is Salma Azaria. And then lastly Zahra Anissa Fakira. So first of all is our goals of doing this project is first of all will be automate toy recognition and weight measurement to improve efficiency. Then there is build strong teamwork and share knowledge among the team members. Enhance technical skills in AI, hardware integration, database management, and Internet of Things. And then, of course, the final is deliver the project according to the planned timeline. Next will be continued by my friend Zahra Anissa Fakira.
Hello, good morning everyone. So I'm the representative from the front-end team. So what we do is the first one is we build the UI design using Figma, and then we build the program using Next.js, Tailwind CSS, and the TypeScript, and then our data is stored in MongoDB. Okay, so this is the front-end architecture. So the first one is we are designing the UI in the Figma, and then we build the website in the Next.js and using Next.js, Tailwind CSS, and TypeScript. And then we also use the Fast API. This is like from the backend team. And then the last one is we also connect it to the database using MongoDB. Okay, so this is the example of our design. So there is the register page, and then this is the login page. So why we are using the Figma? The first one is because it is like user friendly. The interface is so simple, so that's easy to use for us. And then the second one, it is also offers a variety of plugins, so to speed up the design process. And then the last one is also have the real-time collaboration, so we can work together at the same time. Okay, so the next one will be explained by Mieko.
Okay, so I will explain the remaining tools that we use to build the website. This one is Next.js. So why we use Next.js? Because the Next.js provides seamless integration with tools like TypeScript and Tailwind that I will explain later. And then, so because it has tools like that, it makes the development process more efficient. So this is just one example of the code here that makes the use of both TypeScript and Tailwind inside it that make this this object in the website. Next is Tailwind CSS. This used to stylize the object inside of the website. For example, we have this example code and this overview page right here. Next is TypeScript. So TypeScript is similar to JavaScript, which is a programming language that are already used in web development, but it ensures we use the correct type of data, such as number or text, in the proper way. So for example, this code right here, it inputs weight in number type. Lastly, MongoDB. The website uses MongoDB as its database. For example, here in the register page, we have username, full name, password, and then in the upload image, we have upload image, category, and product weight. So this will be explained more by the backend team. Rafi.
So for the next part will be our work from the backend team. So what do we do in the backend team? We develop the API using FastAPI for the CRUD operations. The API acts as a middleware that will facilitate data transactions between the website and the MongoDB database. And we also set the database up to be used to store the toys data. Apart from that, we also developed the login authentication mechanism using JSON Web Token. And for the architecture, the API consists of 4 main functions, namely create, read, update, and delete. And there are 2 read functions. The first one is to get all the items, and the other one is to get just a single substance of data in the database. And the API will do the corresponding command to the data in the MongoDB database. And we used FastAPI for the API, and it is able to do data transactions with the MongoDB database. On the create and edit function, the API will be sending 5 data variables, which is title, expected title, weight, contributor, and the image of the toy. And the next part will be the MongoDB. We are using MongoDB Atlas for the database used to store the image of the toys, as well as the admin account credentials. The storage capacity of the database is 512 megabytes because it is the free plan of the MongoDB. And all the data mentioned in the previous slide is stored in this database. And the image is stored in base64 format, since MongoDB cannot store data in blob format, as in SQL and MySQL. Next part will be machine learning and will be explained by the team.
Namaste everyone. So for machine learning team, for our project, our team is focusing on handling, developing, and selecting the most suitable model, which in this case we are using the YOLO model. We train the model in the Google Colab, and then once the training is complete, we hand the model over to the back-end team for integration and use. This is the tools that we use, Google Colab as our environment and for utilizing the model training, and we store our data in our Google Drive. Now, this is our architecture where first we wait the data from the data labeling team, and then they will give us the data for our model, and then we from the machine learning team will use the data for training our model, which is YOLO, and then the trained model would be selected which one is the best and suitable for our project, which in this case our YOLO v11, and then we will give the best PT to the back-end team to integrate the model with the first one. And this is the good case, which we choose which one is the best model for our project. This is the prediction of YOLO v11, and this is the prediction of YOLO v10. This one is a good case because both of the images can be predicted by these 2 models, but this one is the bad case, whereas you can see the YOLO could predict this one, but YOLO v10 cannot. And furthermore, for this selection, I will give it to my teammates. Gilang, could you?
Thank you, Putra. So why did we pick YOLO 11 and not YOLO v10? Well, there are several reasons why we did. The first one is better model architecture. YOLO v10 is more recent. YOLO 11 is more recent than YOLO v10, so it obviously have a better model architecture, and that matters because the second point, improved performance and precision. Now, there's the change is not very huge, but it is still an improvement on performance both in training and then the output of the precision. And then the faster inference speed. Now this is not very noticeable in smaller models like ours, but in larger models, and especially when a separate inference unit is needed, the inference speed is much faster, well, not much faster, it's just approximately 2%. And then the last reason is YOLOVision doesn't support image segmentation. Actually, I want to rephrase that. YOLOVision doesn't have a dedicated model for separate image segmentation. This is the parameters we use for training. The image size at 640 pixels by 640 pixels, which is pretty standard. The batch size at 16 and the epochs at 50 because we have around 800 to 1,000 image in the dataset. I think the workers is at 2, which is the CPU threads used to load the image into the model. And then lastly, the device is CUDA because we use the T4 GPU in the Google Cloud. Using those training parameters, this is the results that we gain. This is the comparison between several YOLO V11 models. As you can see, this is the segmentation models, and we went from nano, small, medium, large to extra large. These values are the mean average precision or MAP within the 50 percentile and the 95 percentile of the model. Due to size constraints in Vercel, we couldn't use the large and extra large models, but our selection still includes the nano, small, and medium. And as you can see, the and as you can see, the best precision that we encountered was in the small model, so that's what we went with. Now next I want to talk about what we can improve. Now the model does well enough with so before we talk about that, we support 4 name classes. There's animal, robot, and vehicle. If it's quadrupedal or has 4 legs, it's probably an animal. If it has wheels instead of legs, it's probably a vehicle. If it looks humanoid with sharp features, it's probably a robot. And if it's not sure what kind of toys it is, like for example like general toys or toys that does not appear to be any kind of shape, it's gonna put it in the miscellaneous or MISC name class. But as you can see, there's a huge imbalance here regarding the amount of data that we have. There's a lot of instances of the vehicle data, of the vehicle image, but there's not a lot of the animal, miscellaneous, and especially the robot image. For further developments, I would suggest balancing out the data set so that the precision would be better as well. And the next one is IoT and sensor integration, which I will give to the IoT team.
Okay, for the IoT and sensor integration team is we implemented IoT technology to connect physical sensor. In this project, we use button load cells, and we use 3 button load cells for toy scale measurement, and with a digital application, to the website using API. And the focus was on designing the system that accurately collects data, process it through the PZ, and transmit it seamlessly to the backend using PACE API. Okay, for the architecture will be presented by Ahsan.
Okay, for the architecture for the IoT teams, we built the system, the physical system. We use button load cell, 50 kilograms, which is we have 3 of them, and we make them in shape of triangle. So yeah, we can make sure that the center point of the weight is on balance. And then we use the fidget bridge for input because we have more than one sensor, so we cannot just connect the sensor to the microcontroller. Since we don't have microcontroller, we just use the fidget bridge for input to transfer or maybe just switch data from voltage and convert it to the signal. And then we use USB to the computer, to the laptops, and then the bridge gives signals to the laptops and read by the server, and then the API sends the data to the websites. Next, so this is the tools, this is the sensors, this is the front of the sensor, and this one is the back. So this is the front of the, I think it's the top part of the sensor. So it will be like this, and this is the back. It has 3 holes which is we can mount to the base plate. And then this is the actual plan that we built. So actually at first we want to make it with metal plate, but since it will be hard to machining because we don't have any machines and we don't know where to do the machining, and since we know some of our students, some of our college, we have some friends in the mechanical engineering, so we ask for the acrylic. So the materials that we use here is the acrylic 5mm thick, and then we do some marking and drilling so the sensors can be mounted on the base plate, and then we stick glue on the top of the top plate, and so this is how we made the system. Next is the FAST API that will be explained by Corinne.
Okay, for IoT team we use FAST API, so same as the backend team, so it will be easier to combine. FAST API is used to create an API that enables seamless communications between the load cell system and the application. It handles tasks like starting measurement, retrieving data, and controlling functionality, ensuring speed and scalability. So as you can see here, this is the API. We have 2 endpoints actually, it's wait and tear. On the terminal, we have like channel 0, channel 1, and channel 2 because we have like 3 button load cell. But on the API, it's only gonna show you the average weight. Next, it's data labeling. So for this project, data is the main thing actually because it is like the foundation of the intelligent system. So what we do in labeling team is there is 3 main things that we do. First, we collect the data, and second, we processing the data, and the last, we format the data. The first thing is we collect the data, so we come to Kokkiri factory like in the first 3 weeks or more. We take a photo from the toys, like from different angles, so that the machine will know the shape well, and then we do the segmentation and we do the labeling like for the detection and segmentation. And this one is first we use like box labeling, so the machine will know where is the toys, and then we do the segmentation labeling, so the machine will know what kind of toys it is. And the last, we gather all the labeling data, become one folder so that we can send it to the machine learning. And the next process will tell by Agil.
Okay, so for the next process is of course we're gonna process the data because data can be quite difficult to work with, and some data have something wrong in them. For example, this data, some of my friends probably labeled some classes wrong, so we have to correct it. With some data can also be in a different format entirely, which we need to fix up. So all we do is that we use Python as a scripting language, so we can process the data. So we can basically automate the processing data. We also can use Python to check if the data is even correct, which we can use in code, since we don't really want things to be wrong. So next is the simplest job to do. We just format the data to the YOLO format. Since some data format are kind of different, we change it to this. And after that, the format is pretty much simple. It's basically just that one, the image and label and classes txt. That's basically YOLO format. So our job is pretty much just moving folder into another folder. Okay. I think that's all.
Yeah.
So, Hussein explain this.
So these are some of our struggles. First of all, we'll be combining the AI model with the hardware like the load cell sensor, because the IoT team said that it's different from where they normally use the sensor, and then it is hard to define, test, and use new technologies. Of course, this is our first time doing IoT and machine learning and website combined. And then there's complex calibration of the load cell sensor for accurate weight measurement. Like I said before, this is for their first time using this kind of sensor, and limited tools to make it work, and then not enough time to test everything thoroughly. And then of course there are a lot of bugs during the live testing, but there are some solutions of our struggles. The first will be we make the APIs and test it step by step to ensure smooth integration, and then regular meetings to track progress and share knowledge, and also bonding, and then follow calibration guidelines and integrate sensor data with Python API. We also focus on high priority features and scheduled extra testing session, and of course conducted multiple testing phases and prepared a quick bug fix plan. There's also some of our photo. We will do a live demo for the application.
So this is the register page. So in the register page for the admin, so it is use the username first. So Hussein can make a username, and then Hussein will also like use the full name, and then you can put your password, and then the last one is the confirm password. Okay, so after register, you can go to the login page. For the login, it is using the username and then the password only. Okay, after that, this is our. So this is the dashboard. So in the overview page, there is the total contributors, like the total accounts, and then the total products, and then the total categories, which there are 4 categories. So this is the contributors overview. So this is like how much they upload the image, and then this is the categories. There are vehicle, robot, animal, and news. So this is the performance model page. So there is a table consists of the image, the title of the photo, the category, the weight, the contributor, and then you can edit or delete. So first we can input the data. So we can we can upload the image first. So for example, this is the animal, and then the title is like the dinosaur, and then you can click the categories button. So there's like kind of error, so we will try to use another photo. Okay. So after Hussein click the categories button, so this is like the actual result, which is vehicle. And then we can also input the expected result if the actual result is not correct. And then we can like enter the weight of this product. So for this we still input it manually. And then we can submit it. Okay, so after we submit the photo, it will like show in the table. So this is the photo that we input. Okay, and then we also can edit. So we can edit the title, the weight, and then the expected result only. Okay, so after update it, so for example, like the name, the title is changed. Okay, and then the weight is also changed. Okay, and you can delete it also. So as you can see, it is all deleted. Okay, so this is the contributor page. So actually, like this is like all of us. So there's the username, the full name, and then the contribution or like the total of the image that is being uploaded.
Yang timbangan admin ganteng gua gitu.
Timbangan. Ahsan apa?
Ahsan Hasbi ya.
Gimana keluarnya baca? Enggak di gimana itu.
Bisa keluar full screen.
Escape.
Makasih sudah dapat.
Ke atas.
Itu iya sampai muncul.
Nah.
Okay, so the next one we will demo the weight.
아유 떼야지 그러다.
우리는 맛이
그러니까 웹 페이지는 이제 이렇게 만들었고 이제 무게 재는 거를 보여주는
jalan kerja.
Ayo udah kasih aku semua tunggu foto. Poin yang satu lagi bisa nggak?
Ini ke paling ini
Poin
paling
yang
bawah kan?
Iya, iya.
bakter.
dia
Udah gitu deh suruh gue ya.
Belum. Ini udah. So here's how we measure the weight of the toys. So at first, when there's nothing on the measurement device, the weight will be 0. And then after we put some toys on it, yeah, the weight changes. As you can see, it's around 700, and this is in grams, so it's about 0.7 kilograms. And there's some kind of error because the sensor, and we use 3 sensor, so it's some, yeah, I think. So we add the error. So one of the sensor have error range at 1%, I think. Yeah, so 3 of the sensor will be 3%. But as you can see, the weight is pretty much very stable. So there's will be only 705, 704. So it's only changed for 1 gram. So I think it's very accurate. So because that's our motto actually, precision is our motto. And yeah. So this is how we measure the toys. That's it. Yeah.
Okay, udah.
So after we put back the toys, the weight will be 0 again. Yeah. So yeah, that's it. Thank you.
We step into the light, the future's calling. Hussein, Mieko, Zara, dreams are evolving. Gilang on the rhythm, Aya brings the spark. Together we ignite, creating in the dark. Amaze, vision clear, but charcoal's away. Rafi keeps it real, Agil learns today. Ahsan on the wire, Hasbi turns the tide. Kokkiri united, we're taking this ride. The toys tell a story, a past to rewind. With tech in our hands, a new way to find. From pixels to sensors, dreams take their flight. We're building tomorrow with passion tonight. Kokkiri, we're rising, the beat never ends. And our adventure flow future's in our hands and we believe. Labeled the moments, frame them in gold. Each toy has a purpose, a story untold. Aya paints the picture, Ahsan makes it real. Hasbi builds a bridge with electric zeal. Hussein leads the line, Zara sets the scene. Mieko's melodies shining colors so keen. Together we rise, no dream too extreme. At Kokkiri factory we're living the dream. The toys tell a story, a past to rewind. With tech in our hands, a new way to find. From pixels to sensors, dreams take their flight. We're building tomorrow with passion tonight. Kokkiri, we're rising, the beat never ends. Innovation flowing, we're more than just friends. With every code we write, every dream we weave, the future's in our hands and we believe. This is our moment, this is our time. From the smallest toy to the brightest shine. Every effort counts, every spark will glow. Together we're unstoppable, let's go, let's go. Let's go, let's go. Yeah, yeah. We're coding the beat, we're sensing the flow. Gilang drops the bass, the energy grows. Rafi spins the mix, Butcher flips the scene. Agil on the rise, chasing that dream. Kokkiri, we're rising, a beat never ends. Innovation flowing, we're more than just friends. Yeah, with every code we read, every dream we weave, the future's in our hands and we believe. Yeah, Kokkiri, we shine so bright. From the plastic dreams to the stars tonight. Together we're stronger, we'll never give in. This is our legacy, let the journey begin. Yeah. We step into the light, the future's calling. Hussein, Mieko, Zara, dreams are evolving. Gilang on the rhythm, Aya brings a spark. Together we ignite, creating in the dark. Amazed, vision clear, but charcoal's away. Rafi keeps it real, Agil learns today. Ahsan on the wire, Hasbi turns the tide. Kokkiri united, we're taking this ride. The toys tell a story, a past to rewind. With tech in our hands, a new way to find. From pixels to sensors, dreams take their flight. We're building tomorrow with passion tonight. Kokkiri, we're rising, the beat never ends. Innovation flowing, we're more than just friends. With every code we write, every dream we weave, the future's in our hands and we believe.
So in 3 words, I would say it's definitely collaboration and learning and what do you call it again? Sorry, it's kind of hard to say it in in a simple sentence, but it's definitely, I think, collaboration, studying, learning, or technological advancement. I think it's because this is our, basically technology. This is our first studying artificial intelligence, and yeah.
Interesting, challenging, and refreshing, maybe. Yeah. Okay.
Okay, great.
There we go. Thank you.
I would say challenging, entertaining, and exciting.
I would say fun, challenging, and memorable.
3 words, my overall experience is fun, challenging, and definitely, how to word it out? Like, how you became more knowledgeable? Yeah, smarter. Yeah, something like that.
translate this experience in 3 words, I would say like this was very challenging, very exciting, and very innovative.
Okay, so I will describe this project in 3 words. It's like challenging, interesting, and meaningful.
This project is challenging, collaborative, and rewarding.
Okay, so this project in 3 words: exciting, grateful, and proud.
Okay, I would say teamwork, commitment, and exciting. Thank you.
Kerjasama, kemudian futuristik atau masa depan, dan yang terakhir itu adalah keyakinan. Thank you.
Okay, thank you. 1, 2, 3. Praise it. Kokkiri.
Kokkiri.
Okay, guys.
Thank you.